Welcome to Aryavat Center for Theoretical Physics. Today we will learn the divergence and curl of any vector field. So what is the divergence? Divergence is nothing but a measure of a vector field from the point, spread of the point. This is the point A, and from this point how much any vector field can spread. This is vector field, and spread of the vector field at certain point is called divergence. If F is the vector field which is the function of x, y and z, then its component will be f1, x1, x, y, z, I plus f2, x, y, z, j plus f3, x, y, z, k. This is the vector field, and f1, f2, f3 is the component of the vector field. Then we define divergence. Divergence of any vector field is del dot f x y z is equal to divergence of f x y z equal to del f1 by del x plus del f2 by del y plus del f3 by del z. This is the divergence of vector field, and divergence of vector field is scalar. Divergence of vector field is the scalar quantity. If F is the two-dimensional vector field, I plus f2 x y z, then we can write divergence of f is equal to del f1 x plus del f2 by x. This is the divergence of vector field. So basically, divergence of any vector field tells about the spread of the vector field from certain point. We can also say that divergence of any vector field nothing but a flux of the vector field. Positive divergence, if divergence of f is positive, then we can say that point is source, and if negative, then sink. So if divergence of any vector field is positive, then we can say that point is a source of the vector field, and if negative quantity comes up, then we can say that point is sink of the vector field. And if divergence of vector field f is 0 or divergence free, then we can say that the vector field is solenoidal. So vector field f is solenoidal if divergence of f is 0. Example of solenoidal vector field is magnetic field. Divergence of magnetic field is 0, and this is the example of solenoidal vector field. It also means that vector field is divergence free. We can calculate the divergence of any vector field. Example is calculate the divergence of this electric field R divided by RQ. We have to find the divergence of this electric field. So divergence of this electric field is, we know that R divided by RQ is xi plus yj plus zk divided by x square plus y square plus z square 3 by 2 to the power 3 by 2. Now we have to find the component partial differential of this E, or del E by del x. Del E by del x will be y square plus z square minus 2x square divided by x square plus y square plus z square to the power 5 by 2, or divergence of electric field E will be 0. So if E is equal to R divided by RQ, then divergence is 0. After finding out del E by del x and del E by del y and del E by del z, and after summing of this component, this one and this one, del E by del x plus del E by del y plus del E by del z will be 0. So divergence of this electric field E is 0. It means it is divergence free, or it is solenoidal. So this is how we calculate the divergence of the any vector field. Now we are going to calculate curl of the vector field. Imagine there is a pond in which water is flowing in certain direction. This is the flow of the water in the pond, and this is the example of vector field. Imagine there is a wheel which is rotating at fixed axis. This is the wheel which is rotating at its axis O. Then the water particle will also rotate with this wheel. So this rotating water particles is example of the curl of the vector field. So curl of the vector field F is integrated by del cross F. This is the curl of the vector field, and it is a vector quantity. Vector quantity. So curl of any vector field f x y z equal to I j k del y del x del y del y del y del z f1 f2 and f3. This is the formula of the curl of the any vector field, or we can write curl of f equal to del f3 by del y minus del f2 by del z. This is ith component, del f1 by del z minus del f3 by del x, this is jth component, plus del f2 by del x minus del f1 by del y, this is k. So this is x component, y component and z component. This is the formula for curl of any vector field f. This is curl of any vector field x, y, z. So curl of any vector field f is equal to minus y I plus x j. We have to calculate the curl of this vector field. So curl of this vector field is, it has only two components, f1 and f2. So this will become del x by del x plus del y by del y k is equal to 2k. This is the curl of this vector field f. So we can calculate easily the curl of the vector field with the help of this formula. Curl of the vector field. So if curl of the vector field is 0 but divergence of this vector field is positive, it means it has no rotation. It means it has no circulation. We know that curl of any vector field tells about the circulation of any vector field. Circulation of any vector field is nothing but a curl of the vector field, and divergence is nothing but a measure of spread of the vector field. So if spread of the vector field is positive, it means divergence of the vector field is positive, but curl is 0, it means it has no circulation or it has no rotation. So we can say that a vector field has positive divergence but 0 curl. So this is the example of curl of the vector field.